Okay. Now, punta na tayo doon sa topic na at hand, which is on frequency analysis. For this, I'll give a lecture demo. I would like you to follow along, if you could, using, say, MATLAB online. Of course, if you have Python, fine. Hindi ko lang nga alam kung paano yung equivalent in Python. But everyone who has a UP Edu PH account can do MATLAB online. Okay? So in preparation for the next experiment, this is the lecture demo. Guys, go to mathworks.com. Have you opened your free MATLAB? Kasi if not, go ahead and get MATLAB and tell that you have a UP, University of the Philippines account. And it will allow you to get a free MATLAB account. Okay. How many of you are already using MATLAB online? Or MATLAB? You can download even. So if you want not to be online all the time, you can download. So here, I'm going to go to my account. For example, nakuha ko na. And you can, just like Google Colab, if you're familiar with Google Colab, you can do calculations online. So click here, MATLAB online. And there. Did you notice that? Left side, meron pang pwede kang mag-download mismo ng MATLAB, and so you can go offline. Right. Okay. So what I want to do right now is discuss the frequency analysis. It's pag nag-measure tayo, may experiment tayo, kailangan tayong mag-measure. Isang important question is a free parameter. How often should you sample? What is the interval between sampling? Or essentially, what should be your sampling rate? Okay, like right now, let's make a sine wave. Right. So in MATLAB, it's as simple as first you tell it that you have a range of time that you want to have. Here you have a square bracket. You start from 0, the spacing, say, would be 0.01, and the ending would be, say, 2 times pi, for example. This is in seconds. Assume natin seconds. Of course, we can put seconds here, but let's assume that this is in seconds. Oh, sure, I can just have it 2 seconds, not 2 pi seconds. Wala naman problema yan. Okay? Usually, we put a semicolon to avoid the output showing up on the screen. Then we just say y equals sine 2 times pi times t. That's it. And we can go ahead and plot t versus y. If we want to make it look discrete, we can have dots representing the data points. Okay, so we're making an artificial signal here, guys. And once we've written this short code, this is a section. We can simply run this section. And if there's no error, the data will come out here. As you can see here in the workspace, nakalabas, and you can see the output over here. So, ewan ko kung ganito rin nakikita niyo sa Google Colab, but and Python, Jupyter, parang ganun din lang. You can see that here. Notice that, assuming this is an artificial data, where is our sampling here? So parang artificially, sinample natin siya every 0.01 second. Ito yun, guys. We have, when we're doing an experiment, we have control over this. Dun sa Arduino, linalagay natin yan, delay. Okay, delay. Tapos in milliseconds yung linalagay natin doon. Okay? So fine. So remember this sine wave because it's finely sampled. But what if okay, sige, kunyari continuous, no? If I want to make it look continuous, tatanggalin ko lang tong discrete points na to, right? And if I run it again, it would look like a continuous signal like this. But sa totoo lang, may spacing siya. Now, okay. Now, why is it important that we know this part, guys? Yung how often should we sample? Watch what happens. Now, I want to have the next plot overlay on this same signal, all right? So I'll use the command hold on, and all the plots will keep drawing on this same sine wave. Suppose ito na yung sampling interval natin. So yung unang sine wave, assume natin this is the actual analog signal. Now, by sampling it, essentially we discretize it. So suppose ang sampling interval natin mas coarse. Like this is kung seconds to 1/100. Diba? So parang teka, tama ba? 0.01. 0.01 of a second siya nagsasample. Okay? If we invert it in a way, parang it's sampling in 1 second, you have 100 samples, right? Which is why dito makikita natin 201 samples. That 201 comes from the fact that we also start at 0, right? So essentially, every 1 second, there are 100 samples, okay? Now, what if in every second, so essentially, ilang milliseconds to, guys? 10 milliseconds, ano? In 1 millisecond, in 1 second, there are 10 samples. Tama, sorry. In 1 second, there are 100 samples, okay? So parang 10 milliseconds, tama ba? 10 milliseconds. Okay. Ngayon, what if tagalan natin? Sabihin natin 0.1. Yan. 2. Okay. Ganun pa din. Drawing natin yung ys equals sine 2 times pi times ts naman. Okay. And then, i-plot natin to. But this time, let's plot just the points to indicate that this is discretized. I will run the section again. It would look like this. Okay. Now, teka, lagyan ko na pala ng section break. Section break. So para ito na lang ulit-ulitin natin. What if I make it coarser? Like every half second, doon ako mag-sample, no? Right? This time I'll make it blue. No, let's have an X. Or kaya yan. Meron yan. Runs as run section. So ito lang yung run niya if you press this. Okay. Coincide. You see the X there? Now it's here and here and here and here and here. Okay. Okay. You see those points, those points with X's, nandun lang sila. Okay. Now, ano yung sabihin yan? Problema yan Pag nag-capture tayo, tapos kinonect the dots lang natin, ang dating is parang 0 lang ata, no? Ano mo? Parang 0 lang Parang puro 0 lang yung natatamaan itong X na to, no? Let's run this again from the start. Let's clear this. Ano mag-clear nito? Okay. Clear all. Clear. How do I clear this thing? Ito muna tayo. Clear all. Ulit. Run natin to. Itong first part. This is the clean signal. And ito yung sample signal at half millisecond. Ay, half second capture. Taas ka dyan. Hindi ko ang kailangan ko. Ito yung kailangan ko. Ano ba ito? Alis ka dyan. Ay, joke. Ano ba yan? Ito, no. Alis ka dyan. Hindi dito. How do I get you out? Yan. Okay. Now, how about this? Let's run this section. Okay. So again, no, na-sample natin, sakto lang nga, during the time na 0 yung signal, doon siya lumalabas. Pangit. Now, what if taasan pa natin to? Gawin natin, 75. No? One section. Tapos gawin natin na circle naman to. Circle. Natin kung saan to pupunta. Well, ito na. Nakita nyo? This, then this, then this. Ikot tayo dyan. Hindi natin nakukuha yung itsura ng sine wave. What does this tell us, guys? The sampling matters. This just demonstrates na if we have a discretized signal, kung pangit yung choice mo ng sampling interval, either you will miss the signal entirely or you'll detect something which isn't the signal at all. Right? Tignan nyo, pag nag-connect tayo ng dots, like if we connect the dots here, we see a different signal instead. Sorry, hindi ko pala na-press ng buo. Okay? Ang tawag dito, guys, wag iba yung nakikita mo kaysa ito yung actual signal, aliasing. Alright, aliasing. So ayaw natin ng aliasing. By the way, dito sa not a paid advertisement, but you can put text. Like aliasing. Yan. Di ba? Ting. Tapos pwede pa natin lagyan. Yeah, bongga, di ba? Ting. Yan. Alright. Okay. So, seeing a signal different from now. So, paano yan? What if we have no idea of the signal? We have two options, no? Either we know the idea or the highest frequencies of the signal, or we have no idea of the sample signal at all. Anong gagawin mo? Paano ka makaka-decide kung ano yung sampling interval na ilalagay mo sa digital acquisition device mo? Of course, the idea is the smaller the sampling interval or the more frequent you sample, the better. The downside is you run out of space quite easily. Another example, balik ako dun sa favorite example ko sa satellite. Do you know, guys, na SD card ang ginagamit sa loob ng satellite para makakapture ng image data. But that can run out very quickly. Alam nyo ba, pag gagawa kayo ng satellite, dapat redundant yung systems nyo. Dapat dalawa-dalawa. So just in case nag-conk out yung isang SD card, meron ka pang isang SD card na backup. So dalawa yung SD card na linalagyan mo ng data. So kunyari 4 gigabytes, no? Or 16 gigabytes. Mabilis lang yan kasi capture ka ng image immediately. Ubus na yan. So what happens? Pag nasagad na yung space ng SD card, buburahin niya na yung mga lumang data. Now, dapat ma-download mo na yung data sa ground receiving station bago niya paburahin yon. But ito yung reality. There are some space or rather storage space considerations in certain applications. Now let's move on to the Fourier transform. Okay, how do you do a Fourier transform? Simple. For a single one-dimensional signal, it's as simple as, okay, let's put a section break here. Okay. Let's say Fy is the Fourier transform. So you call it this way, FFT of y. All right. That's it. So the fast Fourier transform, by the way, may tanong ako, guys. When was the first time you encountered the Fourier transform? I suppose you have already. Somebody tell me kung na-encounter nyo na yung Fourier transform back in your mathematical methods or some other subjects. May nag-chat. Second year po sa P6117. Optics, ma'am. Okay, good. Naalala nyo pa perhaps yung Fourier transform. Pwede ka magsulat ng equation dito eh. If you have a function y of t, you multiply it by e to the minus 2 times 2 pi na nga ba yun pi? Ganito ba? Ano pa ganyan? Yun. ft. Okay. Then you output y of f. This is integral ano ba infinity? Ano ba infinity, guys? Pag LaTeX. Alam eh. Basta, integrate from infinity to negative infinity to infinity. Okay? Yeah. Yeah. Okay. All right. So this is the Fourier transform. It will be a function of frequency once you apply this equation. Oh, kulang tayo. Wait lang. Edit natin. Kulang ng I. Complex to, guys. Okay. Tandaan, exponential of minus I something something pwedeng isulat as cosine of 2 pi ft minus I sine 2 pi ft. So, the Fourier transform result is complex. Tingnan nyo, pagka-run ko nitong FFT, lalabas siya complex. So, punta tayo doon sa live editor. Run lang natin itong section na to. Run. And check out the workspace. Makikita nyo na yung output Fy is a complex number, double. So may imaginary part and a real part. And you can now immediately plot that. Wait lang. Ay, sorry. Joke. So let's plot the real part. Real of Fy. Okay. Then let's just run this section para lang makita natin. Okay. This is the real part. Now, I like to emphasize that this x-axis or the x-axis here has to be properly corrected. Dapat ma-express natin to as the proper frequency range. But one thing you will notice, the real part is even, meaning if you zoom in, this part here is just a mirror image of this part here. So essentially, pag flinip mo to sa kalahati, pareho lang itsura nila. Okay? Now, have a look at the imaginary part. The imaginary part of the Fourier transform. Again, I'll just run this section. See here, the imaginary part of the Fourier transform is an odd function. Once again, odd functions, imi-mirror mo lang yan. So cut it in half, flip the other one mirror the other one along the x-axis, and you have an odd function. Okay. Now, normally, ang habol natin is the modulus or the absolute. Meaning, ano ba yung absolute? Yan yung square root of real squared plus imaginary squared. Pag kinuha natin yung absolute ng Fy, para na rin nating in-square muna yung signal, no? Now, the thing is, kapag absolute Fy, essentially, pag na-square, parang mong in-square yung signal, kinuha mo yung square root niya. Essentially, what you have is like power. Diba nga, P is equal to IV squared. So, essentially, parang power ito na observe natin kapag inabs natin. Which is why sometimes Fourier transform na naka-absolute is sometimes known as a power spectrum. So, run natin tong section na to. And ito combined na real and imaginary parts. And this is what you would see if you have an instrument that can measure frequency. Parang mauli kita. Ang dami kong i-edit para sakasakaling. Okay. Pumatong. O nga, naka-hold on pa kasi ako. Anyway. Ngayon, ang lalabas lang dyan is essentially naka-positive na lahat kapag naka-Fourier transform. Now, ingay aso ko. Ngayon, palitan natin tong x-axis kasi dapat pag nagpa-plot ka sa MATLAB, papakita mo x-axis, y-axis. Pag hindi mo sinabi kung ano yung values ng x-axis, gagamitin niya lang index. Index meaning since there are 201 samples, 201 0 to 201 lang to ang lalagay niya. This has no physical meaning maliban sa placeholder kung nasaan yung data. So physically, to make use of the Fourier transform, we have to convert this x-axis into physical variables, meaning frequency. Fourier transform converts a time signal into a frequency signal. So if this is seconds, we need to have the plot in hertz. So how do you do that? So ganito yan. The Fourier transform and its time signal, they have an inverse relationship. Okay, and if this is n samples and corresponding to 2 seconds. Okay? Ganito. The inverse, no? So remember, we sampled. The original sampling was, for example, for this signal, kasi ang in FFT natin is the Y signal, which is the finely sampled sine wave. Look at its sampling. It's every 0.01. So if we zoom in on the original signal, okay, open yung figure window. Lumabas ba yung figure window, guys? Sensya na, hindi ko nakikita yung itsura. Can you confirm if a pop-up window showed up in your screen? May nag-chat. Yes po, thank you, Andrea. Okay, all right. This is in time. Kapag tinignan natin na 0.01, zoom in pa natin, 0.01. 0.01. 0.01. Zoom in pa natin. Okay. So kumbaga, ito kasi connect the dots to but mangyari niyan, there is an interval, 0.01 pala, kaya mas maliit pa kaysa sa dito. 0.01, every 0.01 sampling may point. But the thing is, kung kunyari, ganito, example lang kunyari from here to here is 0.01. Kung ganito kaliit sa time, pag maliit sa time, mahaba sa frequency. Tandaan mo and vice versa. Pag mahaba sa time, maliit sa frequency. So, anong kinalaman nito doon sa frequency axis? Let's zoom out. The time interval that you chose to sample the signal decides the maximum frequency. Again, sulat ko yan para parang lecture na. Ay, joke pa tayo sumara. Insert tayo ng text. To determine the frequency axis, let's related to Fmax, maximum frequency. Okay. Time interval dt. So in this case, it's 0.01 yung original. Okay. So this way. dt is equal to, or rather 1 over dt is equal to f max, right? All right. So in our case, if dt is 0.01, okay, f max, what is 1 over 0.01? F max is 100 hertz. Okay. All right. Now there are n samples, di ba? Ikaw din ang nag-dictate niyan. Bakit? Ikaw yung nagsabi kung hanggang saan ka magsasample eh. Tandaan nyo guys, pag nag-start kayo sa 0 at nag-end kayo sa an integer number, please include the 0 in the count of samples. For example, dito, even though this is sampling 100 samples a second and you're saying, okay, I will sample 2 seconds, don't forget that 0 is also a sample, which is why the number of samples is not 200, but it's 201 in this case. So if there are n samples, in our case, it's 201. And so essentially, kung alam mo na yung F max, ang next na kailangan mo malaman is DF. Di ba? Ano yung interval ng DF? So from here, you can find that DF is equal to F max divided by the number of samples. Okay? Which is 100 hertz divided by 201. Okay? So, yun yung DF natin. DF equals 100 divided by 201. 0.497. 0.4975. That's it. Same column. Okay? And that will be enough to allow us to write the DF. So here, balik tayo dito. Lagay natin yung frequency axis. All right. We can start from 0 to point in space of 4,975, and the max would be F max. Oh, I didn't write F max. F max is equal to 1 over dt. Oh, what's dt? Well, we can change that later, but dt is equal to 0.01. Okay. And what is this? Let's hardwire this. So programming, guys, you don't want to put constants here. You want it to be as flexy as possible, right? So sasabihin natin, df is equal to f max divided by n. Wait, hindi pa natin na-define yung n. Okay, kanina, n is equal to 201 eh. Mamaya, pwede rin nating makuha yan from the size of the signal mamaya. Okay? Right. Dahil dyan, meron na tayong frequency axis. And again, dahil dyan, pwede na natin isulat yung F. Katulad kanina, nag-plot tayo, may time axis and y axis o xy. Dito, meron na rin tayo frequency axis and signal itself. Okay? Ngayon, kung tama yung ginawa natin, kung ano yung frequency dito, yun din yung frequency na lalabas after taking the Fourier transform. Okay? So, let's run this. Teka muna, you might ask, ano po ba ang frequency dito? Well, the frequency here is 2 pi. Dapat may F naught dito eh. That's the frequency of the Fourier transform. Okay? So, for example, F naught equals 1, then dapat lalabas natin dito F naught. Okay? So just run it again. I'll just run it again. And then I'll put off the hold off. Then I'll just run this section to create once again. Okay? Saan na ba siya pumunta? Hindi ko alam. Nag-work na ba? Burahin muna natin to, guys. Clear all output para bonggang bagong buhay. Okay, ito. Run section. Yan. Gawa muna tayo ng discretized sine wave. Ito na. Okay? Sure, fine. Palitan natin yung frequency. Walang problema yan. Gawin natin mas frequent. Oh. Yan. Oh. Okay. Tandaan nyo ha. F naught equals 4 Hertz. Okay? Okay. Teka, nasa na yung sample natin? Nasa na yung, ba't nawala yung workspace natin dito? Okay. Anyway, ito. Gawin naman natin to. Oran na natin to, guys. Ito na yung Fourier transform. Ay! Nangyari dito. Bakit naging 202 yung samples? Ay, joke. Wait. Okay. Teka, DF dapat to. Okay. Sorry po. Sorry na. Okay. Teka, may mali. Dahil naging 202, sumobra. So, ibig sabihin, kasi kasama yung 0 no? So, ibig sabihin, dapat bawasan natin ng isang DF to. Okay? Para maging 201. Tama lang yan, guys. Okay? Kasi kasama nga yung 0. Yun. Okay. Heto na, may lumabas na peaks. Ang tanong, nasa 4 Hertz ba? So, tingnan natin yung kung ano to. Pwede bang masilip ko? Ayan. Medyo nasa 3.98. Halos malapit na. Itong isa, nasan siya? Ito, nasan ka, girl? Okay. Yung unang peak, dalawang peaks nakikita natin. And as I was saying, mirror image lang yan. It doesn't mean na meron siyang frequency at 960,199. No, hindi ganon. Oh, by the way, teka. 0 DF. Okay. Munti ka ng 4. That's fine. It's almost 4. Ideally, sana nasa 4. Pero, have a look here. Hindi ibig sabihin na yung sine wave natin ay may frequency na 96 Hertz na nakasama. No, doesn't mean that. Remember, a Fourier transform, mirror image lang ito. Mirror image lang ito, folks. So, hindi yan yon. So, ibig sabihin, kung mirror image siya, hindi to useful. This part here is useless. It's just a mirror image. However, when you do a Fourier transform analytically, you will find that it has negative frequencies. Negative frequencies. May meaning bang physically ang negative frequencies? Wala. Analytically lang merong lumalabas. Physical relevance, wala. No such thing as negative frequency. Mathematical lang. Analytically lumalabas na may negative F. Useless itong half na part na to. Okay? So, in fact, for all intents and purposes, we can shift this and put this dun sa negative half, and that's it. Meron na tayong parang analytic Fourier transform, which is why there exists a function FFT shift. Okay? And what this does is it will shift this half here into the negative part. So parang 0 to negative frequency lalagay niya. Paano yan? Yung frequency natin hanggang dito lang hanggang 0 lang actually we can rearrange this such that pwede siyang mag-range from negative frequency to maximum frequency half. But notice wala na ito. This is empty frequency. This is just a mirror image. What does that mean? The relevant frequencies are only at the halfway point. Halfway point. So, ibig sabihin, if F max is equal to, in our case, 100, actually, ang relevant lang na frequencies na kaya niyang ma-detect ay up to 50 Hertz, which is 1/2 of F max. Which means, guys, pwede nating, if we FFT shift, if I don't do anything, that FFT shift, how does it look like? It will look like this. Okay. Kaso mo, yung frequencies natin naka-relative to 0 pa. We have to shift the 0 dito sa gitna para magmukhang symmetric na negative frequency, positive frequency. And so now, yung magiging range natin is 1/2 F max over, so do you understand? F max df, and F max 1/2 minus 1 df, no? Para maging 201 samples pa rin. So we just negative pala to. Sorry, negative. Okay, so negative F max over 2 to positive F max. Okay. And if we run this section, now we see that it is centered na. Okay? Centered na siya. Let's check the frequencies again. Oop, -4. And this is at negative. Nangalanganin na. -3. Mukhang pumangit. Ano? Nag-shift pa yung frequency ng shinif natin. But that's the idea. Baka mamaya dapat dito yung minus df. Sandali lang Tapos dito yung plus df. Just double check. Run uli natin yung section. Run section. Teka. Okay. So inurong ko lang yung plus df pala. Plus df. $10 na ba? Ay, 11:30 na ba? Ano pa naman time, di ba? Okay. What time it is? Oh, na ba? Okay. Run. Nag-run na ba? Run section. Yun. Okay, let's check again. Nasaan na po yung peak? Shift lang. Roughly, kuya, wait. Ito, nasan to? Yun, medyo sumobra, 4.22. Medyo sagad ng konti. But that's it. So palitan natin yung, sige, palitan natin to. Paglaro natin, hindi eksakto, no? Tataka ko ba't kaya hindi eksakto? Max over. Okay. Yun nating 5. Yun nating, tignan natin. So, the point of all of this is, watch this. Sige, 25 hertz. Roughly, dapat mag-4 to, mag-eksaktong 4. Unfortunately, there's something kulang, no? We have to figure out where it is. There are I'm hesitant to do this, but sige, I'll remove this. Oh, there are 200. Oh. Wait lang . Okay. I'm hesitant to do this. It will not work. Sige, okay lang. Sige. Okay. Roughly, magpupunta siya doon sa kung saan yung frequency. There is something wrong in my code a bit. I'll just debug, but more or less na andon. Parang shifted siya by 1. Can't remember why. Okay, I'll put this at 25 hertz and dapat mag-react rin siya ng ganon. Di ba, guys? So, I'll run again this section to create the frequency, the sine wave. Okay? And then I'll run again this section to get the frequency. And dapat, yun, see that? So nandito na siya, and let's have a check kung ano yung frequency niya. by clicking the point. And there it is. Nasa 25, halos 25 na rin. Okay? Okay. So kung may error man na konti, it's because, do you see this? The result should be a Dirac delta, but there is some leakage of energy because of the sampling dito. Okay. Pataas na ng pataas yung frequency, guys. So, pasagarin pa natin. Do you notice something? Siyempre, pag tumataas yung frequency, lalapit at lalapit siya doon sa dulo. Right? So, okay, 45. Gawin natin 45. Okay. 45 hertz yan, ano? So, ibig sabihin, may kikita natin, medyo pupunta na doon siya sa bandang 45. Run natin to. Ah, wait, dito. Ito. Ayun na, lapit na sa ano, lapit na sa 50. Okay? Okay, again. Anong value nito? Yan, mas malapit sa 45. Yan, rin. Negative, malapit rin sa 45. Ayan. What if at 50? Saktong 50. Ano kan mangyayari dito? Sige nga. Nagplano ba? Weird ah. Kailangan ko bang dalawang beses i-press? Yan. Yun! Weird! Look at that, guys. Anong klaseng signal yan? We've hit the limit. And look at the signal, oh, and the value. It's just zero, guys. Wala niyo yung ginawa natin kanina. Ano na kaya mangyayari dito sa Fourier transform nito? 10 to the negative 12, and it doesn't make sense, right? What happened here? Ito yung sinasabi ko, guys, na the choice of your sampling interval gives you the limit to how high the frequency you can detect. And this is what is known as the Nyquist sampling theorem. Ito na. So, Nyquist sampling theorem. Tandaan, yung Fourier transform, pag Fourier transform natin yung signal, pag tinignan natin yung output niya, kalahati lang nun yung relevant kasi the other half is just a mirror image. And therefore, the Nyquist sampling theorem tells us ano ang DT mo. What should the sampling interval DT be if the highest frequency in the signal is F max? Okay? Pwede rin niyang baliktarin. Teka, ayaw kong gamitin yung F max, no? S max na lang. Okay. Okay? Or another question, or we can flip this question, we can ask, what is the highest frequency signal which sampling tama ba yung English ko, guys? Can detect. Okay. And ang sagot is this. Kapag alam natin yung sampling interval DT, okay? Alam natin na yung Fourier transform range ay F max of FFT is dt. Diba? Ginawa natin yan kanina. But, only relevant. Which, therefore, frequency max is equal to f max over 2 or 1 over 2. Yun. Okay? Anong ibig sabihin nito? dt. Kapag ang sinet mo na sampling interval sa iyong Arduino ay 1 second or 1,000 milliseconds, 1 second, 1 second. Anong ibig sabihin nito? Hanggang sa anong frequency lang yung kaya mong ma-detect? Ano yung limit frequency mo? Okay? So sabi dito, yung signal mo lang na ma-detect, no? Diba? Ganyan, di ba? Pag ginamit natin sa Arduino, delay 1,000, ibig sabihin 1 second yan. No? What signals can you detect? Na, sabi dyan, the frequency ng signal na pwede mo pang ma-detect is something less than this. Equals 1 over 2, ano yung dt? Seconds, no? 2 times 1. So, ganyan. Okay, so ibig sabihin, 0.5 Hertz lang. Signals as low as 0.5 Hertz lang ang pwede mong ma-detect pag ganyan. Okay, balik na rin naman natin. Another example. Guys, the human ear is capable of hearing from 20 Hertz to 22,000 Hertz. Kaya natin yan. So, ang favorite example ko nga, 20 Hertz, kaya natin pakinggan. So, that's 20 times a second. So, if you flap your hands or any object 20 times per second, if you can do that, maririnig mo na yan. Yan. Pero ang highest pitch na maririnig natin is 22,000 Hertz. So kung ang frequency max natin ay 22,000 Hertz, gagawa tayo ng microphone. Ano dapat yung sampling interval ng microphone natin? So, di ba frequency max equals 1 over 2 dt? Ibig sabihin, dt should be equal to 2 times frequency max, which means 2 times 22,000 Hertz, which means 44,000 Hertz. And kung titignan nyo sa mga high fidelity audio capture devices, binibida nila na ang sampling nila ay at 44,000 Hertz. Because that would capture every possible sound the human ear can hear. Ay, 44,000. Seka, wait. So, sorry. Yan ano, frequency max is 44,000 Hertz, which means, sorry, wait, may bali ako. Teka. 2 times frequency, 1 over pa pala. Yan. Teka, frequency pa lang to. 1 over dt, up natin yung 2, 44,000. So, dt is equal to 1 over 44,000 second. Sorry. Which is 1 divided by 44,000 second is, let's go ahead and 2 point. So 22, essentially 22 microseconds. Approx. Every 22 microseconds. Or 23 approximately, right? So ibig sabihin guys, kung gagawa kayo ng high fidelity microphone, tapos i-attach nyo sa parang Arduino-like device na magdi-digitize ng audio signal, dapat ang sampling interval mo ay 23 microseconds para wala kang mawawala na signal na mai-escape na high pitch na hindi mo maririnig. Okay? Yan. So what this tells us, this is the important lesson here guys. The Nyquist sampling theorem gives us a limit. Kung ikaw ay nag-set ng DT, it gives you the limit kung ano lang hanggang saan lang frequencies ang madidetect mo. On the other hand, kung meron kang frequency na gusto mong makatch, it advises you up to what value of DT you should enter. Malinaw ba guys? At dun sa ating experiment na gagawin, ite-test natin yung detection limit ng ating LDR. O, doon naman tayo, balik tayo sa experiments guys. Malinaw ba? At bago ang lahat, may tanong ba tungkol dito sa important na theorem na to? May tanong? Wala? O sige, balikan natin yung experiment guide kasi dito siya magiging relevant guys. Okay. So we will use the Fourier transform. So ito yung second experiment report. No? You apply Fourier transform in light and sound sensors to measure frequencies in light and sound signal. So first, determine the Nyquist limit of a sensor. You program a data acquisition device to sample without processing. So Fourier transforms, write about the concept and how and tell how the discrete Fourier transform is used and programmed. And now we go to the light flicker signal. No? Naalala nyo last time, by the way, nakapost na yung mga videos ng lectures. So pag pumunta kayo sa Google Classroom, inedit-edit ko na yan, tinanggal ko na yung mga dead air. So para mabilis-bilis na. So nandun na yung mga lectures natin. So balikan nyo yun, nakikita nyo kung paano i-program yung LDR and yung demonstration sa strobe light. So here, you can find, you can see kung kailan mag-aalias na yung LDR kapag kung kunyari tinaasan mo yung frequency tapos Fourier transform mo yung signal na linalabas niya tapos mali yung signal na linalabas niya, like for example sinasabi niya, oh this is the frequency, whereas yung frequency ng probe mo is something else. Okay, so doon natin makikita kung nag-aalias na siya. Alright, sa sound signal naman here, lahat ng musical instruments, kayo ba may mga musical instruments kahit man lang? Kung wala, use your voice. Okay? So, we here will use Audacity, the program, to analyze the audio signal. So, in the next meeting, we will play around with Audacity kasi may built-in siyang Fourier transform. Magdala kayo ng, ito, hindi Arduino ang gagamitin natin. Gagamitin lang natin yung computer nyo. Gagamitin din natin yung earphones nyo for our microphone. Hindi na tayo gagamit ng microphone sensor. Ng sound sensor, your earphones are enough, or even the microphones from your MacBook. Okay? Just get a musical instrument if you have. Again, if none, use your voice. And then we will capture that using Audacity. And we will also analyze the Fourier transform from within Audacity. Okay? May tanong? So we will continue about this next meeting. And also next meeting, sasabay na rin natin yung pang third experiment. Kasi total, gagamit din tayo ng Audacity dito. So next meeting, please remember to install Audacity. Okay? And don't forget to bring earphone. If you have a spare, fine. If not, well, we can just use the bare microphone from the laptop or computer. Right. Stop share. So experiments 2 and 3, we can continue discussing next meeting. May tanong ba? Malinaw ba guys? Nasundan nyo ba? Nakapag-MATLAB ba kayo? Feedback naman dyan. Problema pag itong, hindi ko nakikita mukha niya eh. Papakita nga ako ng mukha. By example, choose virtual background muna. Check. Blur. Blur muna ng background. Pakita ako ng haggard kong face. Okay guys. Rest muna tayo. Masa kayo dyan? Balitaan nyo naman ako sa inyong buhay. No questions po so far. Nasundan nyo ba? Sino ba nagma-MATLAB dyan sa inyo? Na-open nyo ba yung MATLAB nyo? Yes, no? It's okay if no. Sundan nyo lang yung yung video pag na-post ko na. Okay. Raised hand. O bakit John Carlo? Anong problema? Ikaw yung nakapag...
yung MATLAB po.
Thank you. Okay. Next question is, meron pa bang walang Arduino sa inyo? Dito sa mga present ngayon. Kasi may spare ako. I-gift ko kasi sa mga pamangkin ko for Christmas. Bumili na ako ng 3. So sabi ko, 2 lang naman silang papadalhan ko. So meron pa akong spare. So pag may kilala kayong wala pang Arduino, I can donate that. Okay? Okay? Mukha namang wala nagre-react. So akin na lang yun. Pero kung may kilala kayo na nahihiya lang magsabi at walang Arduino pa, I can give that away. Next question is, how are you? Hoy, sagot. How are you? Walang sumasagot. Tawag nga ako ng isa. Kali, kumusta? How are you?
Hi, ma'am. Okay lang po.
Basta ACADS. Ready na ba kayo sa exam? Sa 184, first module? Take home ba yun? Take home yun, ano?
Yes, ma'am. Take home po.
Kaya yan. Okay. Sige. At least na-move, ano? Ano pa ba? Yung mga, naghahabol ba kayo ng mga requirements? Ganyan?
Parang tapos na po yung most deadlines for this sem.
That's
For
good.
this year, sorry.
Okay. If it lessens your stress, again ang sa akin is, ang deadliest deadline is towards kahit January, submit nyo. Ang last experiment natin ewan ko, matapos kaya natin yung lecture natin ng motors by. Basta guys sasagarin ko yan. Kung may meeting pa tayo ng week ng December 22, i-meet ko kayo para lang matapos natin yung lecture demo. Excited ako for you to use the motors. Okay. Alright. Sige, may nag-chat? Kamusta to? Sino nag-chat? No questions po so far. Okay. So kung wala na, sige, that's it for today. Alright. Thank you guys for coming. I hope to see more of you next meeting when we do another lecture demo. Ingat kayo guys. Ingat. Sige. Bye. Sige. Stop ko na. Bye-bye.